So now this video discusses about the algebraic expressions, and basically we'll be talking about what is the algebraic expressions are all about. We'll be talking about the terms, coefficients, as well as the constants, and finally we'll be talking about the like terms and the unlike terms, and also how we can simplify the algebraic expressions in terms of the like terms and actually unlike terms. So stay there and be focused and see what will happen. So if we say an algebraic expression, this is a mathematical expression that consists with the letters as well as the numbers. That is the algebraic expression. So we can have, let's say, 2a. This is part of the algebraic expression. We can have, let's say, 6x. This is part of the algebraic expression. We can have, let's say, 7m minus 2. This is the algebraic expression. We can also have, let's say, x minus 5. This is also part of the algebraic expression. So we have two or more types of the algebraic expressions. We have what we call as the monomial expression. We have what we call as the monomial expression, and we have what we call as the binomial expression. Should be binomial expression. We'll be talking about what is the binomial expression at the end of the day, but so binomial expression, and we have what we call as the trinomial expression. So we'll be talking about what all this is trying to say about. We have trinomial expression, and we can have even more than that. So let's say we have the actually algebraic expression. Let's say if we have 2x plus 1 in this case. So this is a typical algebraic expression, and this expression consists of actually two groups. It consists of what we call it as two groups. It consists of what we call it as the two groups, and these groups are said to be the terms. So the group C that has made up the algebraic expression, we call them as the terms. So in this case, this is the first term and this is the second term. Hence, since it is made up of two terms, it is said to be binomial expression. So actually, which means now you have to understand that the binomial expression, it is the expression with the two terms. It should be the expression with the two terms. That is the binomial expression. What if we have, let's say, 2m? So in this case, this is what we call as the monomial expression. It is made up of a single term. And let's say if we have, let's say, 6m minus 5, this is what we call as the binomial expression. Let's say if we have x minus, let's say, 2i plus 7, this is part of the trinomial expression, as it is made up of three actual terms. So which means the monomial expression, it is the expression that is made up of the single term, and while that of the binomial expression, it is the expression made up of two terms, and that of the trinomial, it is made up of actually three terms. So keep that in mind. Now, let's say if we have, what do you think is a variable? What do you think is the coefficient, and what do you think is the constant? Let's say if we have the, if we have the algebraic expression, which is given as, let's say, 2x minus, let's say, 5m, and let's say minus 6. So this is part of the trinomial expression, as you can see, and it consists of three terms. It consists of three terms. So this is the first term, the second term, and this is the third term, like that. So what is a variable? So if we say a variable, it is said to be the letter that is available in the actually algebraic expression, and it can represent any value. It can represent any value. It can be 0, 1, 2, 3, it can be negative or positive. That is a variable. So it is a letter that can represent any value. That is a variable. So in this case, the variables are given as should be x as well as the m. Those are the variables. So I'm saying we have 3 terms. So there are 3 terms. And the variables are, so we have the variables are, we have x and m. So these are the variables. And how about the coefficient? Now how do you think is the actually coefficient? Now if we say a coefficient, this is a constant, this is the number that is multiplying with the variable. That is what we call as the coefficient. So in this case, the coefficients are, we have 2 and negative 5. Those are the coefficients because they are the ones that are multiplying the variables. Actually, they are the ones that are multiplying with variables. We call them as the coefficients. In this case, the coefficients are, we have 2 and negative 5. Those are the coefficients. Now how about the constant? A constant, it is a number that stands alone. So in this case, negative 6, it is a constant. It is a number that cannot change. That is a constant. Let's say if we have this kind of a case. Let's say if we have, there should be 6x squared. Let me just have it as 6x minus, let's say 4m, let's say plus 7. So in this case we have 3 terms. We have 3 terms. And we have the coefficients. We have the coefficients that are being given as, we have 6 and negative 4. And we have the constant which is given as 7. And we have the variables that are given as x as well as the m. Like that. And how about, let's say if we have this. Let's say if we can have something like this. Let's say if we have, let's say 6m, and that should be plus 3m, should be 3n rather, should be 3n, and let's say minus 1 plus, let's say 2k. So in this case we have 1, 2, 3, 4 terms. We have 4 terms. And what are the coefficients? The coefficients are given as, we have 6, we have 3, and we have 2. And how about the variables? We have m, we have n, as well as the k. And how about the constant? We have it as the negative 1. So that's how you can have it there. That's how you can have it there. And what if, let's say, if we have something about, let's say, a plus, and that should be 2b minus 6. Let's say should be minus half. Let's say minus half m. So how many terms are here? We have 3 terms. Then what are the variables? We have the likes of a, we have b, as well as the m. And how about the constants? There's no constant in the actual expression. But how about the coefficients? Now the coefficients are given as, we have, what is the coefficient here? Coefficient here is the same as, it is given as 1. So in this case, if we have x, it is the same as 1 times x. So which is the same as x. And we have 2 and negative half. So those are the coefficients in that way. And also try to identify the number of variables, coefficients, variables in the following expressions. Let's say if we have 2m minus 7, let's say k plus 4r minus 64, like that. And how about, let's say if we have something about, let's say 6 pi and a minus, let's say, half kr, let's say, minus, that should be 6 pi, should be 6m rather. So identify the number of actual number of terms, actually the variables, and also the coefficients, even the constants as well. And let's say if we have, let's say, should be 2k minus 7m plus n minus 4, let's say, d. So how many terms are there? Then identify the variables, the coefficients, as well as the constant in that way. Now let's see actually extend our discussions by looking at what we get as the like terms as well as the unlike terms. What are actually like terms? What are like terms? And how about unlike terms? So how do you think you can define this? What are actually like terms and what are unlike terms? So as the name itself suggests, like terms, these are the terms that are the same. And while unlike terms, these are the terms that are not the same. And if we are saying that are not the same and that are the same, what is it that we're trying to say? Now if we say like terms, so terms are said to be like if they have exactly the same variables to the same power. We call them as like terms. Actually, otherwise they're said to be unlike terms. So that is how you should have to understand about the like terms and the unlike terms. For instance, let's say if we have 2x to the power 2 and we have, let's say, 3x to the power 5. Let me have this. Now these terms are said to be the like terms because they have the same variable and are with the same power. We call them as, they are said to be the like terms. So we can be able to add or subtract them. So that is, we can have, let's say, 2x squared plus, let's say, 3x squared. We can have everything. We can divide, actually we can add or subtract. How about if we have this? Let's say if we have, let's say, 2x squared and let's say 5x to the power 3. These terms are said to be unlike terms because the variables has the different actually powers, hence the unlike terms. And let's say if we have, let's say, x squared and that should be 2xy, let's say 2x squared y. These terms are also said to be actually unlike terms because they do not have the same variables and also list with the same power. For this case, we have x squared, which is okay. We have 2, which is okay. We have x squared, which is okay. But we have y here, there is no y. So hence, those are said to be unlike terms. So keep that in mind. Let's say we have this case. So in each case, we should have to pick actually the terms which seems to be unlike to others. Let's say if we have the first case, we have 2x, and let's say we have 4x, and let's say we have 3x squared, and let's say we have 10x. So what are the actually like terms? The like terms, we have 2x, 4x, and 8x. And the unlike term, we have it as 3x squared. So keep that in mind. Let's say if we have this, let's say if we have 3mn, and let's say we have nm, and we have, let's say, mn like that, and let's say we have m squared should be n, and let's say we have 5/2, and that should be mn. So what are the like terms in this case? So you should have to understand that, let's say if we have AB, it is the same as BA. It doesn't matter which one has started, but much as we have the product of these two actually variables, so these are said to be the lactams. I'd say in this case this one and this one are the same, hence the lactams. It doesn't matter the order itself, how they are being ordered, but they are the same. So what are the lactams? So in this case the lactams are given as 3mn, and we have nm, and we have mn, it is the same, and we have 5/2 mn. And how about the unlactams? Unlactams, we have it as m square n. So keep that in mind. How about, let's say if we have this, let's say if we can have it as, that should be x square y, and let's say we have xy like that, and let's say we have 3x square y, and that should be 4x square, and that should be y. So what are the lactams in this case? Now the lactams are given as x square y and 4x square y, and also 3x square y like that. And while unlactams to this, we have it as xy. So that is. So try to come up with a list of, let's say, the terms that contains, let's say, 6 lactams and 2 unlactams. So try to have about 6 problems. I want to see how you can have it in the comment section in case you are facing challenges. Now let's see how we can simplify the following. Let's say we have, that is, let's say we have 2x and plus, let's say, 4y and plus, let's say, should be 3m minus x plus 5y. So how do you think we can have to simplify this? So the simplification will be based on the lactams. So first thing, we should have to group all lactams together. So in this case we have 2x. So which term is like to 2x? So we have negative x. So in this case we have it as the negative x, like that. Then we'll go for 4y. So which term is like to 4y? We'll have it as positive 5y, like that. Then finally we have 3m, and the free up to 3m has no partner. We'll leave it in that way. So with the calculator, what is 2x minus x? We have it as x. And of 4y plus 5y, that is given as the 9. And our plus, we have it as 3m. So this is how we can simplify that. And let's say if we have a case like this. Let's say if we can have, and that should be d plus 2d, and let's say plus 5d, let's say x to dm. So how do you think we can have to simplify this? So first thing, we'll just have to correct all the lactams. So we have d, and our host partner is 2d as well, so we'll have plus d, 2d. And this is also another partner, we have it as 5d. And this one has no partner, we just have to leave it as negative x dm. So what are these? We have it as 8d d minus x dm. So we'll have that. And how about, let's say, if we have this? And how do you think we can just have to simplify that? Let's say if we have, and that should be, let's say, 8d minus 2d, and let's say minus 3d, that should be minus 7t. Now all these are the lactams, we just have to simplify them. So in this case, what is negative? Actually, it should be 8d minus 2d, that is 60, and the negative 3d, negative 7t, that is negative 10t. Then here we'll have it as negative 40. So that is the simplified version of that one. And how about, let's say, if we have x plus y plus x plus y. How do you think you can have this? So first thing, we should have the like terms together. So in this case, we'll have it as x plus x, that is a 2x, and a plus 2y. So that is the solution. And how about, let's say, if we have something like this? Let's say if we can have it about, should be 10 minus 5d, and let's say plus 2d minus, let's say, 15 plus, that should be 4d. So how do you think we can simplify that? So first thing, we just have to correct the like terms together. So in this case, we have 10 whose partner is negative 15. So we have negative 15, negative 5, actually 5d. What is the partner for that? We have it as plus 2d and a plus 4d. So like that. So in this case, we have negative 5, and what is that? So in this case, this is, we have it as negative 3 and a plus 4d. That is that should be positive d. So this is the simplified version. So keep that in mind. And let's say if you have this, let's say you have 12 minus, and that should be 4a, and that should be plus, let's say, 6a, and plus 10h minus 1 over h plus 5. How do you think you can have to simplify that one? And let's say if we have something about 5 over 2x minus 1 over 5, that should be xy, plus that should be 6 over 5 x minus xy. How do you think you can have to simplify that one? And also try to understand this. Let's say if we have 7h, and say we have 2g, and that is plus 4 minus 3h. It has to be plus 7g plus 2. How do you think you can have to simplify those? And let's say if we can have, and that should be 4m. Let's say we have 4m and minus m plus 6 minus, let's say, 4m. How do you think we can have to simplify that? So that's how you should have to understand about the actually algebraic expressions, you know, the coefficients and that of the variables, the constant, and how you can have to specify the like and the unlike terms. So thank you.